Good morning, everyone. So welcome to my YouTube channel, Maths Avatarm. Today we are going to see 8th problem set on uniform convergence of function. So still, if you have not subscribed my YouTube channel, subscribe it for such type of problem sets. So let's start today's session now. It is going to be a good session. Consider the sequence of function fn defined on I1 union I2. If fn, option number 1 is given, if fn converging to f uniformly on I1, okay, and fn converging to f uniformly on I2, then fn converging to f uniformly on I1 union I2. Okay. Second option is fn converging uniformly. If the fn does not converge uniformly on I1 and fn does not converge uniformly on I2, then fn converge to f uniformly on I1 union I2. Option number C is fn converge to fn does not converge to f uniformly on I1 and fn does not converge uniformly on I2. Then fn converge to f uniformly on I1 union I2. Okay. None of the above. So let's see this question. Let's solve it. So fn converging to f uniformly on I1. Okay. Okay. So let epsilon greater than 0. Then there exists n1 belongs to n such that fnx minus fx is less than epsilon for all n greater than equal to capital N1 and x belongs to I1. Okay. So let's see question number 1. Also fn converges to f uniformly on I2. Okay. Okay. Then there exists n2 belongs to capital N such that fnx minus fx less than epsilon for all n greater than equal to capital N2 and x belongs to I2. Okay. So put capital N is equal to maximum of N1 and N2. Okay. Then by equation 1 and 2, we have fnx minus fx is less than epsilon for all n greater than equal to capital N and x belongs to I1 union I2. Because I am taking maximum of N1 and 2. So, okay. If x falls in I1, then still it is true. If x falls in I2, still it is true. So what does it mean? It means fn converging to f uniformly on I1 union I2. Okay. So which option is correct? So this option is correct. Please correct this. This is erase this part. Okay. This is extra written thing. So this option is correct. Erase this. So first option is correct. Okay. Second question is which of the following statements is correct? Summation fnx is uniformly convergent. This, then absolute summation is uniformly convergent. If absolute summation is uniformly convergent, then summation fnx is uniformly convergent. If summation absolute fnx is uniformly convergent, if and only summation fnx is uniformly convergent. Okay. Okay. So let this series f and x is uniformly convergent. Okay. Then this implies this is uniformly Cauchy. Is uniformly Cauchy. Okay. What does it? It means summation n goes to m, k, f and x. This tends to 0 as m and k tends to infinity, and this is independent of x. Okay. Now summation n goes to m to k, f and x. I can write a triangularity like this, but this tends to 0 as m, k tends to infinity, and this is independent of x. So what does it mean? It means summation n m k, f and x tends to 0 as m, k tends to infinity, independent of x. Okay. What does it mean? It means this implies summation n goes to infinity and f and x is uniformly Cauchy. If this is uniformly Cauchy, this implies this is uniformly convergent. So which option is correct? So this option, B option is correct. Okay. Now, whether A is correct or not. Now, if A is not correct because I can take this function -1 to power n upon n. This is uniformly convergent. Okay. On R. But you take absolute value, it is not uniformly convergent. Then its absolute value then is what? Summation n goes to 1 to infinity 1 upon. That is not uniformly convergent. This is not convergent even. This is not convergent. Okay. So it is not uniformly convergent. Okay. Not convergent. Okay. Not convergent. So which option? So first option is not correct. Okay. Third option is not correct because it is if and only. So first and third is not correct. So obviously D will not be correct because B is correct. So this series given that this is uniformly convergent on 0, 1. So now this series I will see. Okay. So what is B and X here? I will apply a Abel test here. So what is B and X? Okay. You fix X belongs to closed interval 0, 1. Then this B and X is monotonically decreasing. Why? Decreasing. Why? If you take x is equal to 0, then it is a constant sequence 0. That is monotonically. If you take x is equal to 1, then it is a constant sequence 1, monotonically decreasing. If you take x in between 0 and 1, you take raising power x to the power n. If you have a value in between 0 and 1, raising the power, it will always decrease. Okay. So that is why it is monotonically decreasing. Now, what about now B and x to the power n maximum it can go 1. So this implies B and X is uniformly bounded. Okay, bounded as well. Okay, so this implies by a Abel test, this series n goes to 1 to infinity a and x to the power n, okay, converges uniformly on closed interval 0, 1. Okay, on. Okay, so which option is correct? Uniformly convergent. It is not correct. We have already taken summation -1 to the power n upon n. So this option is not, first option is not correct. Second option is not correct. Third option is correct. D option is not correct. Okay. Now see this question. Summation n goes to 1. Again, this is given that this is uniformly convergent on closed interval 0, 1. Okay. Summation n goes to 1 to infinity a and x to the power n upon 1 plus x to the power 2n. Okay. So what is b and x here? This is b and x. So b and x is equal to x to the power n upon 1 plus x to the power n, 2n. Okay. I can write it x power n upon 1 plus x to the power n square. Okay. Okay. Now b and x is this x to the power n upon 1 plus x to the power n square. So if I am taking x is equal to 0, then this implies b and x is nothing but 0. Okay, this implies b and 0. So I am taking 0 here. Is monotonically decreasing. Okay. Now if I take 1, if I am taking x is equal to 1, then what is this? B and 1, what is this? 1 upon 1 plus 1, that is 1 by 2. So this implies B and G. This is a constant sequence. We can say it is monotonically decreasing. Okay. Constant sequence are monotonically increasing, decreasing both. So I am writing here monotonically decreasing. Okay. So if I am taking x in between this. Okay. I know that if you take any function gy 1 upon y upon 1 plus y square, this function is increasing function, monotonically increasing function. This is monotonically increasing function. Is monotonically increasing function. Increasing. Gy upon g is equal to y upon 1 plus y square is a monotonically increasing function. Okay, increasing function. So now I'm taking this. Then because x is in this range, we have x to the power n plus 1 will be less than x to the power n. Okay. Okay. In that case, what will be happen? G x to the power n plus 1 will be less than G x to the power n. What is this? Tell me what is this? This is x to the power n plus 1 upon 1 plus x to the power n plus 1 का square. That is x to the power n 1 plus x to the power n square. It means what we have, what is this? This is b n plus 1 x. This is b n x. It means this implies b n x is monotonically decreasing for any fixed x in this range. Okay. So finally, we have already checked for x equal to 0 and x equal to 1. So this implies Bnx is monotonically decreasing. Okay. Now by Abel test, because Abel test is applicable in both, Bnx should be monotone. For any fixed x, Bnx should be monotone. Either it is monotonically increasing or decreasing. If it is monotone means monotonically decreasing, then for each axis have to be monotonically decreasing. If I am saying that in monotonically increasing, it should be monotonically increasing for fixed axis, each fixed axis. Okay. By Abel test, summation n goes to 1 to infinity. A n x, x to the power n, 1 plus x to the power 2n converges uniformly on closed interval 0, 1. So which option is correct? First option is certainly not correct. Second option is not correct because third option is correct. We have checked it. Second option is correct. Third option number 4 is automatically exit because we have option which is correct. Okay. So question number 5 we are moving. Okay. So Fn converges to F uniformly on I and G be a function. Okay. So suppose I am taking Fn x. So I am telling that 1 is not correct. I am taking this function under root x. So this converts to this function under root x uniformly. Okay. So I am taking gx is equal to 1 upon x if x is not 0 and 0 if x is 0. Okay. Sorry. I am taking here one function. I am taking here x to the power I am taking here one function. Sorry. First option is not correct actually. Okay. I'm to make something here. I will see it. I'm defining a function Fn. So Fnx Fnx, I'm taking this function. I can take and cleverly define. Okay, nevertheless, first is not correct. Okay, I will see. So first of all, let's see which option is correct. So you see that Fn converging to F uniformly. This is given. Okay, uniformly on I. Okay, so G is bounded. G is bounded. This implies there exists M greater than 0 such that Gx is less than equal to M for all X belongs to I. Okay. So let epsilon is given. Let epsilon greater than 0. Since Fn converging to F uniformly on I, there exists N belongs to capital N such that Fnx minus Fx less than epsilon upon M for all N greater than capital N and X belongs to I. Now, what is Fn Gx minus Fgx? What is this? What is this? Fnx Gx minus Fx Gx. So Gx can be taken common outside. Fnx minus Fx. Okay. So this is less than Gx Fnx. But this is less than M. Okay, and this is less than epsilon M upon M. For all N greater than capital N and X belongs to I. Okay. So this is cancel out. It means Fn Gx minus Fgx is less than epsilon for all N greater than capital N and X belongs to I. Okay. Okay. So this implies Fn G converges to Fg uniformly. We have taken G is bound. If G is bound uniformly on I, if G is bounded on I, okay. 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 So which option is correct? C option is correct. Okay. Okay. So if G is bounded and Fn converges to F uniformly on I, then Fn into G converges to Fg uniformly on I. Okay. Such example exist if G is not bounded. Okay. then Fn into G does not converge to Fg uniformly. Such example exists. Okay. So I am to make that example. Okay. So okay. So I will find that example and I will let you know. Okay. So timing I do not able to consider that example, but I will consider and I will convey the message. Thank you. Okay. So now you move to what option number F1G converge to FG no, uniformly. It is not correct in general because if G is unbounded, then it is not true. If Fn into G does not converge to Fg uniformly, because sometimes option number one, if you are taking any function G, it is possible that if G is not bounded, even Fn G can converge. Fn into G can converge. So if G is bounded, it can convert Fn into G can convert to Fg. Sometimes it can converge and sometimes it cannot. Okay, if G is unbounded. But if G is bounded, then Fn into G converts to Fg uniformly or not. Okay. Okay. I will construct that example and I will let you know. Okay. So now move to last question. Okay. Now, if AB belongs to R such that A is less than B, is C less than B, and Fn converges to F uniformly on AB, and for a function G defined on AB, which of the following statement is correct? Fn into G, it converges to Fg uniformly on AB. Okay. Fn into G does not converge to Fg uniformly on AB. Fn into G converts to Fg uniformly on AB if G is contained on AB. None of them. So it is simple. You see that I am taking option number. Suppose G is continuous on AB. If G continuous, every continuous function, this is a result, every continuous function on a closed interval is always bounded. Always bounded. Okay. Always bounded. If you take any continuous function on a closed interval, it is always bounded. Okay. So it means since G is continuous on closed and bounded interval, every continuous function on a closed and bounded interval is always bounded. Since G is continuous on closed and bounded interval, on interval AB, closed interval, because A and B belongs to real number, so AB is closed and bounded interval. By previous question number, G is continuous on closed and bounded, so G is bounded on AB. Okay. Now by previous question number 5, by previous previous question number 5, we have Fn into G constitute Fg uniformly on AB. Okay. Okay. What was the previous question? Previous question was that here my I is closed interval AB. Okay. So same question is here, but only I is changing, and I is changing. In place of I, there is a closed interval AB, and G is continuous. Continuous function is always bounded on closed and bounded interval. Okay. So by question number 5, this we have which option is correct? Option number C is correct. Okay. Option number C. So we have completed all the question of this problem, sir. So thank you very much for today's session. If you have any problem and or issue related to this session, okay, you can comment me on my YouTube channel. Okay. So thank you very much for today's session. Thank you very much. We will see you in next session. Thank you very much. Okay.